Mechanization or mechanization is the process of changing from working largely or exclusively by hand or with animals to doing that work with machinery. In an early engineering text, a machine is defined as follows. Every machine is constructed for the purpose of performing certain mechanical operations, each of which supposes the existence of two other things besides the machine in question, namely, a moving power, and an object subject to the operation, which may be termed the work to be done. Machines, in fact, are interposed between the power and the work, for the purpose of adapting the one to the other. In some fields, mechanization includes the use of hand tools. In modern usage, such as in engineering or economics, mechanization implies machinery more complex than hand tools and would not include simple devices such as an ungeared horse or donkey mill. Devices that cause speed changes or changes to or from reciprocating to rotary motion, using means such as gears, pulleys or sheaves and belts, shafts, cams and cranks, usually are considered machines. After electrification, when most small machinery was no longer hand-powered, mechanization was synonymous with motorized machines. History. Ancient times water wheels date to the Roman period and were used to grind grain and lift irrigation water. Water-powered bellows were in use on blast furnaces in China in 31 AD. By the 13th century, water wheels powered sawmills and trip hammers, to full cloth and pound flax and later cotton rags into pulp for making paper. Trip hammers are shown crushing ore into remetallica. Clocks were some of the most complex early mechanical devices. Clockmakers were important developers of machine tools including gear and screw-cutting machines, and were also involved in the mathematical development of geared designs. Clocks were some of the earliest mass-produced items, beginning around 1830. Water-powered bellows for blast furnaces, used in China in ancient times, were in use in Europe by the 15th century. De Re Metallica contains drawings related to bellows for blast furnaces, including a fabrication drawing. Improved geared designs decreased wear and increased efficiency. Mathematical geared designs were developed in the mid-17th century. French mathematician and engineer Desargues designed and constructed the first mill with epicycloidal teeth, California, 1650. In the 18th century, Involute Gears, another mathematical-derived design, came into use. Involute gears are better for meshing gears of different sizes than epicycloidal. Gear-cutting machines came into use in the 18th century. Industrial Revolution. The Newcomen steam engine was first used to pump water from a mine in 1712. John Smeaton introduced metal gears and axles to water wheels in the mid to last half of the 18th century. Smeaton also conducted a scientific investigation into the design of water wheels which lead to significant efficiency increases. The Industrial Revolution started mainly with textile machinery, such as the spinning jenny and water frame. Demand for metal parts used in textile machinery led to the invention of many machine tools in the late 1700s until the mid-1800s. After the early decades of the 19th century, iron increasingly replaced wood in gearing and shafts in textile machinery. In the 1840s, self-acting machine tools were developed. Self-acting tools displaced hand dexterity and allowed one unskilled operator to tend several machines. Machinery was developed to make nails, California, 1810. The Fourdrinier paper machine for continuous production of paper was patented in 1801, displacing the centuries-old hand method of making individual sheets of paper. One of the first mechanical devices used in agriculture was the seed drill invented by Jethro Tull around 1700. The seed drill allowed more uniform spacing of seed and planting depth than hand methods, increasing yields and saving valuable seed. Mechanized agriculture greatly increased in the late 18th and early 19th centuries with horse-drawn reapers and horse-powered threshing machines. By the late 19th century, steam power was applied to threshing and steam tractors appeared. Internal combustion began being used for tractors in the early 20th century. Threshing and harvesting was originally done with attachments for tractors, but in the 1930s independently powered combine harvesters were in use. In the mid to late 19th century, hydraulic and pneumatic devices were able to power various mechanical actions, such as positioning tools or workpieces. Pile drivers and steam hammers are examples for heavy work. In food processing, pneumatic or hydraulic devices could start and stop filling of cans or bottles on a conveyor. Power steering for automobiles uses hydraulic mechanisms, as does practically all earth-moving equipment and other construction equipment and many attachments to tractors. Pneumatic power is widely used to operate industrial valves. 20th century. By the early 20th century, machines developed the ability to perform more complex operations that had previously been done by skilled craftsmen. An example is the glass bottle making machine developed 1905. It replaced highly paid glass blowers and child labor helpers and led to the mass production of glass bottles. After 1900, factories were electrified, and electric motors and controls were used to perform more complicated mechanical operations. This resulted in mechanized processes to manufacture almost all goods. Categories in manufacturing. Mechanization replaced hand methods of making goods. Prime movers are devices that convert thermal, potential or kinetic energy into mechanical work. Prime movers include internal combustion engines, combustion turbines, water wheels and turbines, windmills and wind turbines, and steam engines and turbines. Powered transportation equipment such as locomotives, automobiles and trucks and airplanes is a classification of machinery which includes subclasses by engine type, such as internal combustion, combustion turbine and steam. Inside factories, warehouses, lumber yards and other manufacturing and distribution operations. Material handling equipment replaced manual carrying or hand trucks and carts. Mechanized agriculture. See Mechanized agriculture. See also Productivity Improving Technologies, Section 4. See also List of agricultural machinery. In mining and excavation, power shovels replaced picks and shovels. Rock and ore crushing had been done for centuries by water-powered trip hammers, but trip hammers have been replaced by modern ore crushers and ball mills. Bulk material handling systems and equipment are used for a variety of materials including coal, ores, grains, sand, gravel and wood products. Construction equipment includes cranes, concrete mixers, concrete pumps, cherry pickers and an assortment of power tools. Powered machinery. Powered machinery today usually means either by electric motor or internal combustion engine. Before the first decade of the 20th century, powered usually meant by steam engine, water or wind. Many of the early machines and machine tools were hand-powered, but most changed over to water or steam power by the early 19th century. Before electrification, mill and factory power was usually transmitted using a line shaft. Electrification allowed individual machines to each be powered by a separate motor in what is called unit drive. Unit drive allowed factories to be better arranged and allowed different machines to run at different speeds. Unit drive also allowed much higher speeds, which was especially important for machine tools. A step beyond mechanization is automation. Early production machinery, such as the glass bottle blowing machine, required a lot of operator involvement. By the 1920s, fully automatic machines, which required much less operator attention, were being used. C. Mass production. Military usage. The term is also used in the military to refer to the use of tracked armored vehicles, particularly armored personnel carriers, to move troops that would otherwise have marched or ridden trucks into combat. In military terminology, mechanized refers to ground units that can fight from vehicles, while motorized refers to units that go to battle in vehicles but then dismount and fight without them. Thus, a towed artillery unit is considered motorized while a self-propelled one is mechanized. Mechanical versus human labor. When we compare the efficiency of the laborer, we see that he has an efficiency of about 1% to 5.5%. Internal combustion engines mostly have an efficiency of about 20%, although large diesel engines, such as those used to power ships, may have efficiencies of nearly 50%. Industrial electric motors have efficiencies up to the low 90% range, before correcting for the conversion efficiency of fuel to electricity of about 35%. When we compare the cost of using an internal combustion engine to a worker to perform work, we notice that an engine can perform more work at a comparative cost. 1 liter of fossil fuel burnt with an IC engine equals about 50 hands of workers operating for 24 hours or 275 arms and legs for 24 hours. In addition, the combined work capability of a human is also much lower than that of a machine. An average human worker can provide work good for around 0.9 horsepower, while a machine can provide for far greater amounts of work. For example, it takes more than 1.5 hours of hard labor to deliver only 1 kWh, which a small engine could deliver in less than 1 hour while burning less than 1 liter of petroleum fuel. In most situations, the worker will also want compensation for the lost time, which is easily 96 times greater per day. Even if we assume the real wage cost for the human labor to be at $1 per day, an energy cost is generated of about $4 per kWh. Despite this being a low wage for hard labor, even in some of the countries with the lowest wages, it represents an energy cost that is significantly more expensive than even exotic power sources such as solar photovoltaic panels. Levels of mechanization. For simplification, one can study mechanization as a series of steps. Many quantify students refer to this series as indicating basic to advanced forms of mechanical society. Hand muscle power, hand tools, powered hand tools, e.g., electric-controlled, powered tools, single-functioned, fixed-cycle, powered tools, multi-functioned, program-controlled, powered tools, remote-controlled, powered tools, activated by workpiece, measurement, selected signaling control, e.g., hydropower control, performance recording, machine action altered through measurement, segregation, rejection according to measurement, selection of appropriate action cycle, correcting performance after operation, correcting performance during operation. Bibliography. Roomley, Edward A. The Passing of the Man with the Hoe, The World's Work, A History of Art. Time XX. 13246-13258. Retrieved 10 July 2009.